So differentiation, and we're going to be looking at differentiating exponentials and logarithms, some of our favorite topics. So hit pause, copy the heading, lesson objective. When you're ready, hit play again. Right, some notes in the first instance. Three results we're going to need. If y is equal to the exponential of x, then dy over dx is also equal to e of x. If y is equal to e to the power of k of x, where k is a constant term, then dy over dx is going to be equal to the constant k times e to the power of k of x. And one more, where y is equal to log of x, then dy over dx is equal to 1 over x. So if you write down these three results, we're going to look at an example then. So, example. Show that the derivative of a to the power of x is equal to a to the power of x times log of a. So, let y be equal to a to the power of x. I've got the x to a power, so what I'm going to do is I'm going to take logs on both sides. So that leaves me with log of y equals log a to the power of x. It's a power here, so I want to bring it down beside the log, so I'm going to use the power law. So I've got log of y is equal to x log of a. Now I'm going to take exponentials on both sides because I know that the exponential is the inverse of log. So e of log of y is equal to e of x log a. Now because they're inverses, e of log of y just leaves me with y is equal to e of x log a. Now the results we looked at earlier, we had when y is equal to e to the power of k of x, that constant, that means if we differentiate it, dy over dx leaves us with k e to the power of k of x. Now I've got a constant term here, it's log of a, so if I differentiate this, dy over dx, it's going to be log of a, which is my constant, put a times here, multiplied by e to the power of x log a. Okay. Now I'm going to use my power law again. This is equal to log of a times e to the power of log of a to the power of x. So I've used my power law the reverse way. But now I know that e of x and log of a are inverses, so they cancel each other out. So that leaves me with log of a times a to the power of x. I can rearrange that. So dy over dx is equal to a to the power of x times log of a, which is what we were trying to prove. So what I want you to do is to hit pause, copy that down, and when you're ready, hit play again, and we'll look at another example. Okay, good. Okay, let's have a look at this example here. Find the derivative of y equals e to the power of 3x plus 2 to the power of 3x. So, dy over dx is going to be equal to, in this case, straightforward enough. Take that constant, 3 e to the power of 3x plus, in this case, 2 to the power of 3x. So it's very much like the example we just did. So we take our term, so it'll be 2 to the power of 3x, and we're going to multiply that by, let's put this in brackets, the log of 2 to the power of 3, which is the constant. So we can leave it in that form, or we can write it as, if we use the power law, 3 e to the power of 3x plus 2 to the power of 3x, which is multiplied by, bring the 3 down, 3 log of 2. Okay, so hit pause, write down that example, and we'll look at one more. So have a look at this example here. We've got y equals log of x to the power of 3 plus log of 7x. So let's write it here. Y is equal to log of x to the power of 3 plus log of 7x. First things first, because it's cubed here, I'm going to use all my laws of logarithms, power law. So that leaves me with 3 log of x plus log of 7x. Now looking at 7x, I can use another, let's put this down here. I can use another law to split these two, 7 and x. I use the, is it coming back to you? The addition law, plus log of 7 plus log of x. Addition law for both of those. Now I've got log of x, or 3 log of x here, and log of x there, so that leaves me with 4 log of x plus log of 7, which is just a constant term. So that's my y now. I've rearranged it. Excuse me. So to differentiate it, dy over dx is going to be given by, if I differentiate, ignore the 4, differentiating log of x gives me 1 over x. So that's just going to be 4 over x. And that's just a constant, so I can ignore that. So that's my solution. So hit pause, write that down. When you're ready, hit play again, and we'll move on to one more example. Okay, so for this example, we got y is equal to 2 minus 3 e to the power of 7x all over 4 e to the power of 3x. Looks like a challenging fraction. Let's rewrite it here. Y is equal to 2 minus 3 e to the power of 7x all divided by 4 e to the power of 3x. Now I want to do a term by term differentiation, which makes it a lot easier. So I'm going to split this fraction into 2. So that's going to be 2 all over 4 e to the power of 3x minus 3 e to the power of 7x all over 4 e to the power of 3x. Simplifying, 2 over 4 is sitting as a half, so it's a half e to the power of minus 3x, just bring it up so it becomes negative, minus 3 over 4 here, e to the power of 7x over e to the power of 3x. So I can use my index law, and because it's division I can subtract them. So 7 take away 3 leaves me with 4x. Now I can differentiate this. So that's my y rearranged. Dy over dx is equal to, I've got my constant minus 3 there, so multiply by minus 3 becomes minus 3 over 2 e to the power of minus 3x minus, I've got my constant term is 4 there, so it's got to be 4 times 3 over 4, which just leaves me with 3 e to the power of 4x. Good. Hit pause. Copy the example down, and I've got a couple of questions for you to attempt then. So exercise 9b, I suggest on question 1 it might be beneficial to do maybe A, C, D, F and G. If you're ambitious, you might as well do them all. H might be quite a nice one to do as well. Question 2, I'd suggest A and C. D might be quite a nice one to do. And then you can work your way through questions then. It goes up to question number 12. Okay. I'll attach this to the assignment.